When graphing a simple inequality, like x is greater than 3, our goal was to visually represent all of the values of x that were greater than 3, meaning that they would be plotted to the right of 3 on a number line. So after drawing a number line, we plot the boundary point at x equals 3, and then shade all values of x to the right of 3. And we use an open dot at x equals 3 to indicate that 3 does not make the inequality true. Then, all values in our shaded region make the inequality x greater than 3 true. So for example, x equals 4 is in our shaded region, and this is because 4 is greater than 3. However, x equals 1 is not in our shaded region, and this is because 1 is not greater than 3. Graphing a linear inequality involves similar reasoning, although the relationships include two variables. So let's review the previous context. Janet recently purchased an aquarium and wants to buy some goldfish. The salesman told her that the tank is large enough to accommodate up to 20 goldfish. She plans to purchase some combination of fantail goldfish and black moor goldfish. We will let the variable f represent the number of fantail goldfish Janet purchases, and we will let b represent the number of black moor goldfish that Janet purchases. Since the aquarium can only hold 20 goldfish, we are interested in values of f and b, where f plus b is less than or equal to 20, so that her aquarium can accommodate all of the fish that she purchases. So let's look at a graph and think about what a point represents in this context. Consider the point 6, 8. This represents that Janet purchased 6 fantail goldfish and 8 black moor goldfish. And therefore, the total number of goldfish that she purchased was 6 plus 8, which is equal to 14, which is less than or equal to 20. And therefore, this is a valid purchasing option. Similarly, the point 416 represents that Janet purchased 4 fantail goldfish and 16 black moor goldfish, and therefore the total number of goldfish that she purchased was less than or equal to 20. If we keep doing this, we find that all solutions are either on the line f plus b equals 20 or on one side of the line. So points on the left-hand side of this line, so points in the shaded region, make the inequality true, and we call this the solution region. Again, this shaded region represents all points that make the inequality f plus b is less than or equal to 20 true. So these are points that represent valid purchasing options for Janet. Now points on the other side of the line make the inequality false. So these points represent FB values that are greater than 20. So for example, 15, 15, so the point 15, 15 is outside of the shaded region, and this represents that Janet purchased 15 fantail goldfish and 15 black moor goldfish, and so she purchased 30 goldfish in total, which is clearly greater than 20. And so this is not a valid purchasing option. Note that because of the context, we are omitting any points that include negative values of f or b. If we removed the context and just looked more generally at any possible values, we would have additional solutions, as shown in this graph. But for this situation, we will restrict our solutions to quadrant 1. We will see examples of general linear inequalities later in this investigation.